Morning everybody. So now it's Monday morning. I'm going back to doing the mechanics now. What all the lessons and videos that I've done so far means that you can now answer questions 2, 3, 4, 5 and 6 from the exam. Okay, so now I'm going to do the mechanics, which is the question 1. Okay, so we'd actually go back to page 160 with this here. Okay, and that's where the vectors started. So this is like AS vectors. Right, so I've got 160 in front of me on my book. A key point, a scalar quantity has size only. I do know a lot of you will know this already from engineering or physics. Examples include distance and speed. Vector has magnitude and direction. And the examples include displacement and velocity. We can represent any vector between points A and B by the magnitude and direction of a directed line segment written AB with an arrow overhead, or underline A or bold A. I think books quite often have bold A, but because when we're doing our handwriting and stuff, we'll probably use underline A or that one with the arrow. When we write a vector by hand using only a single letter, make sure to underline it. Yeah. Okay, diagram to show bold A, vector A, the directed line segment from A to B. Okay, so the way we do this, we call this one. This is point A, this is point B. We put an arrowhead on there. We say that's A, or they've written it in bold. Okay, we write the magnitude of a vector as magnitude of AB. So that's the size or the length. So we write the magnitude of a vector, so this is, oops, what's happening here? Go away. Oh, Python, go away. Right, let's get rid of that if I can. This is my Python program that I'm learning as well. Okay, well, I'm losing track here. That one, I don't need that there. It's just size of AB, or size of A underline B or A. I personally would probably use that one. Okay, because then it's vector and the two lines around it mean magnitude or size. That one could get mixed. That one there could get mixed up with another A. That one I suppose I might use as well. Right, vectors are equal if they're the same magnitude and direction. So I've got here, I want a diagram of a parallelogram, which has two pairs of equal vectors. So a parallelogram, let me just do that one again. That's more or less equal. So those vectors are going to be the same, and those are. Okay, parallelogram, two pairs of parallel sides. So, yeah. The ones with the single arrowheads on, the two sides with a single arrowhead on are parallel and have the same magnitude and direction. So that's the size and that's the direction. And so does the ones with the double arrowheads as well. Okay, so that's a vector, that vector, vector 1, that's also vector 1 there. And if that is vector 2, that's also vector 2. So they don't have to start from finish at the same point, they've just got to have the same size and direction. Right, multiplying a vector by a number changes its magnitude, but not its direction. Okay, so if we've got, say, if this is vector A, then 2A, or 2 point, that looks, yes, that's 2A, it's maybe a bit longer. 2.1A, we've multiplied it by 2.1. It's got a different magnitude because it's multiplied by 2.1, but the direction's the same. So if we actually sort of worked out the bearing from the north, it would be the same. Because we'll work out the bearing. I don't know, they both look like about 45 degrees, don't they? Which they should be. Okay. So that's that line there. KA is a vector parallel to A and has magnitude KA. So this one, this is the KA, and K is 2.1. Okay. A is parallel to B. The next line here is what I'm up to. A is parallel to B only if A is KB. Okay. So the parallel if one's a multiple of the other. And they can actually be the same vector as in the parallelogram above. Okay, combining vectors AB and BC gives the vector AC. I'm at the bottom now. We add vectors by placing them nose to tail. And I'm going to do a diagram of that one on the next page. And the vector sum of two or more vectors is called their resultant. So what we've got, if we do AB, BC, that's vector A to B. And then if we add on to it, look, nose to tail. So that's the nose, that's the tail of the next one, BC, is the same as the vector AC. Okay, so the vector AC is vector AB plus vector BC. Okay. Two or more points are collinear if a single vector or multiple parallel vectors can pass through the points for a single straight line segment. Okay, so what that means, if we've got a straight line here, so A, B, C, two or more points, they're collinear. Collinear means all lie on the same line. If a single vector, so the single vector AC or multiple parallel vectors pass through the points. A to C passes through A, B and C. Okay, so and it makes a single straight line vector, so they're collinear. That's or you can say A to B and multiple parallels vectors, and B to C, they're parallel and they all pass through the points as well. Which of these have we got? Right, key point. A vector with a magnitude of 1 is called a unit vector. The unit vector in the direction of vector A, so where we are is here, look. So I'm up to now. Is what we do is this is the vector A divided by the magnitude of A. Okay. So this is like A divided by the length of A, so that's going to be 1. Fill in A hat. Yeah, we denote that as A hat. A hat means it's a unit vector in the direction of A. And that needs underlining there. Okay, next point. AB plus BA equals 0. Okay, so this means we're going from A to B and then back from B to A. So we end up with 0 vector. It's got 0 magnitude, undefined direction. So B to A is the negative of A to B. Okay, so the last key point on the page now. A and minus A, vector A and vector minus A have the same magnitude but opposite directions. Okay. Diagram to show vector subtraction. Okay. Diagram to show vector. Yeah. Draw a parallelogram. Here, like so. Okay, so we've got a parallelogram A, B, C, D. They're quite fun to label these corners, going round anti-clockwise. D to B, so my little prompt there says that D to B is D to A plus A to B. Okay. I'm just going to rub these out here because I'm going to use the resultant idea in a minute. We know that they're parallel because it's a parallelogram. Okay, right. So if this is, they call this Q in the book. I'll call it Q. I didn't know what to call it, A or D. Call that Q, and that one P. Okay. So A to D is vector Q. A to B is vector P. Okay, so Q takes us that way, P takes us that way. Okay. D to B, if we want to start at D and end up at B, we've got to go back along this way and then this way. So to start at D and to get to B, we've got to go back that way and then add that one on. So it's minus Q plus P. Minus Q plus P. Okay, which you can write as P minus Q. So basically, vector subtraction, what this topic was about here, vector subtraction means you go backwards along the vector. So that's the positive Q way, that's the negative Q way. Okay, similarly, if we want to go from B to D, we'd have to do a minus P plus a Q, which is Q minus P. Okay. Key point at the top here, subtracting a vector is the same as adding its negative. So example 1. Vector P is the same as what's in the book. My book's slightly different. Yeah. Vector P has magnitude 10 and direction vector due east. So P is 10. If you can north, south, west, east. Okay, so this has got length 10, and this is P. Vector Q, oh dear, what's here? Lots of emails popping up. Vector Q has magnitude 8 and direction 0, 5, 5. Find the resultant of P and Q. I've got what the magnitudes are. So the resultant, so this is P, so we've got to add Q to it, magnitude 8, direction, now that's 0, 55, means 55 degrees from the north. At length 8, so that's 55 degrees. And that's a length 8, okay, and that's your Q. Okay, so the resultant, look, so we've got P in there, and we tack on Q onto the end, and the resultant is the overall one here. Okay, so what we do, we find the resultant, so we need to find the double arrowhead one. Okay, and to do that, we need to work out these bits around the side here. So if that's 55 degrees, that's 35 degrees. This is 8 cos 35 degrees. And this is 8 sine 35 degrees. Okay. Cos, because that one's adjacent. That's the adjacent, and that's the opposite. Okay. So the resultant, horizontal, it's going to be 10 plus 8 cos 35 degrees. We need a calculator for that. they've done it a different way in the book. I'll carry on with this one. I've just got to nip off to find my calculator. Let's look into the kitchen. So my calculator's set into, the book's done it a different way, so I'll do it this way and then I'll show you that the book's got the same way. I'll do it both ways. Calculator set to degrees, 10 plus 8 times cos 35 degrees, 16.5532, and then vertical is 8 sine 35 degrees, whoops, 8 sine, open brackets 35, and that is 4.5886. These are above to 4 decimal places. Okay. So the resultant, you see we've made a right angle triangle there. So that long distance there, that overall distance is 16.5532. And this distance is 4.5886. So by Pythagoras I can work out the length of the resultant. So what we've got is the length, the magnitude. We've got PQ, let's call that R for resultant. The magnitude of R, so it's the square root of 16.5532 squared plus 4.5886 squared. So I'm putting that into my calculator exactly as it is there, 16.5532. I'm going to do open bracket, square root, open bracket, 16.5532 squared plus 4.5886 squared, close bracket. That comes up as 17.2 units. We haven't got any units in here, so just 17.2 to 1 decimal place. Okay. And then the direction. So for the direction, actually you can read what's in the book because I'm going to run out of room to do both ways, and one way is enough. Okay, they've used the sine rule and the cosine rule in the book, and it, you know, but if you read the book, you'll see you get the same answers whichever way you do it. If you want any explanations of the book, let me know. Right, so the direction. Right, what we can do is we can work out the angle there, theta, that I've just drawn in there. And this is theta. We've got the opposite and we've got the adjacent. So we can get tan of theta is opposite over adjacent. So tan of theta is this number divided by this number. So that's the opposite. That's the adjacent. Tan theta is 4.5886 divided by 16.5532. So theta is tan inverse of that there, 4.5886 divided by 16.5532. Shift tan inverse, open bracket, 4.586 divided by 16.552, close bracket. 15.5 degrees, which agrees with the book. Okay, but because the question has given us bearings, I'm going to give the answer in bearings. So the bearing of R is, so the bearing is here. It's this angle here, which is actually 90 degrees minus theta. Okay, so it's 90 minus 15.5. 90 minus 15.5, 74.5. And you, in bearings, you put a 0 if it's less than 100. So 0, 74.5 degrees. Okay. Right, example 2. Example 2. ABCD is a parallelogram. So let's draw that in. Parallelogram. A, B, C, D. E is the midpoint of AC. So let's draw AC in. Let's mark E is there. A to B is P. A to D is Q. Prove that E is the midpoint of BD. So what they're saying is, it's a parallelogram. The midpoint of one diagonal is the same place as the midpoint of the other diagonal. Okay, so E is the midpoint of A to C. Right, so A to C. To get from A to C, we've got to go there. It's either that way, or we can go this way. Okay, but whichever way we go, it's still going to be P plus Q. I'll do it the alphabetical way. So it's the green way, P plus Q. Okay, so the midpoint is going to be half of that one. Half of P plus Q. Okay, so that is actually A to E. To get from A to E, we've got to do a half of P plus Q. Okay, so the next thing we need to do is look at the midpoint of, what does it say, B to D. So to get from B to D now, I'm going to rub out some of these lines. Because they're going to confuse us. To get from B to D, we've got to go back along there and up that way. Okay, so B to D, we've got to do a minus P plus a Q. Okay. We could do that. That's not going to help us to get from. I'm just going to rub this out. I didn't realise an easier way to do it. Prove that. Sorry, I don't want that back. Right, B to D is minus P plus Q, and then the midpoint is half minus P plus Q, which is half of Q minus P. Okay, sorry, there's a few ways to do this. I'm just trying to think of the most efficient way. I'm doing it. It's most efficient just to carry on now. And then to get to, so that's the mid, this is, so what we've got here, this is definitely the midpoint of B to D. Okay, we also say, if we go from B to E now, this is B to E is, so what we need to do is show that B, the idea, the way my brain's saying is to do this, to go from B to E, we need to show that it's a half of Q minus P. Okay, so B to E is minus P plus a half of A to C, because that's E's the midpoint of A to C. We already know that. We've set that up. So it's minus P plus a half of P plus Q minus P plus a half of P plus a half of Q. So it's this is going to be a half of Q, because that one's positive, and then the P's, we've got minus 1p plus a half p. It's minus a half p with a half outside. There. And look, they're the same. The two pink squares are the same. Okay. So that proves that B to E is the midpoint. Okay. The reason why I paused a little bit, I can explain it now. Now we've got the full answer. I started to write B to D, and when I was going to work out the midpoint, it came up as that, which wasn't the same as that. Okay, so that's because that's A to E, and that's halfway between B to D. So we need to use this, do from B to E, and use this to arrive at that, which it does. Right, next one, draw the parallelogram again, A, B, C, D. That is not very neat. I'm going to draw a neat one. E lies on DC, and D to E to C is 1 to 3. So there we are. And that's about 1. Imagine splitting this into 4 parts because it's 1 to 3. There's the E there. Okay, A, E and B, C. B to C and A to E when extended meet at F. Right, I'm going to do a new diagram now because this is, I'm going to start, when I start extending those, it's going to go over the top. So let's, I need to do a small diagram here. A small parallelogram, so I can extend things and not so visually it'll work. Right, A, B, C, D, and E is about there. Okay, so it says A and E and B and C when extended meet at F. So let's do this. Let's extend them. A to E extended, B to C extended, meet at F, which is up there. Okay, and that's 1 there, and that's 3. A to B is P. A to D is Q. A to F is lambda. A to E. Oh, let's go back again. Sorry about that. A to F is lambda. A to E, and E is there, remember? And B to F is mu. That should be, that should lie over that actually. Mu B to C. Okay. Express A to F in terms of lambda, P and Q. Okay. Right, so A, I'll start here. A to F is lambda A to E, and A to E is Q. No, sorry, yeah, P. That's a P there. It's a Q. To get from A to E, I'll do this one I'll do it in a different colour apart from pink. To get from A to E, we've got to go A to D and then D to E. And that's a Q, and then it's plus 1/4 of a P. Okay, that's a Q. That little bit of yellow there, that's 1/4 of a Q. Okay, and that's what we want. Okay, A to F in terms of, so part B, A to F in terms of mu, P and Q. So A to F is also Q, let's get plus mu B to C. So I'll change the colour for this one. Let's do this one in green. So if we could go from A to F this way, it's A to B plus, let's go along there. Okay, so that's another way of getting from A to F. Look, there's A and there's F. Okay. And the first one, getting a lot of emails today, I'm sure you can understand why. The first one is this one here, the lambda A to E. That one is there. So that's, yeah. And that bit there, that's the A to E there. Okay. A to F is in green. So we've got to start from A. We've got to do, that's a P there. That should be a P. Okay, A to F is B plus B to F, which is a mu B to C. And then B to C is a Q, which is P. And B to C, look, that there is actually a Q because it's parallel to this here. So it's P plus mu Q. Okay. So hopefully you understand those. Hence find the values of lambda and mu. Okay, so if A to F is lambda Q plus quarter P, and A to F is also P plus mu Q, what we've therefore got is that P plus mu Q is equals to lambda Q plus lambda times a quarter P. So therefore lambda Q plus lambda over 4P is P plus mu Q. And then we look at the P's, and on the left hand side we've got the P's are going to be purple. Okay, we've got lambda over 4 is 1, so therefore lambda is 4. And then if we look at the Q's, pick another colour for the Q's. Which is, we've got lambda there is mu. That's handy. Lambda is mu, so therefore mu is also 4 because lambda's 4. And that concludes that one.